Okay, after that last video on CPUs, after the last two videos on CPUs, this video should be a lot easier to understand and easy to follow. I recognize that all those CPU numbers are a lot to take in, so that would be a great video to watch twice because that would be very helpful. Moving on, number two. If we start our demonstration earlier on this slide back here that said there's four responsibilities. We just talked about the CPU. We talked about how they schedule with round robin. We talked about the Intel and the AMD. Now let's look at memory. So a couple uh, terms that you need to know. Memory is one of the most misused terms in a computer. People come in the computer store and talk about my computer's out of memory. I need more memory. How much memory does my computer have? And they mean multiple things. So we have to be very clear. So traditionally speaking, memory refers to the temporary and the fastest storage. So in this video, we're only talking about the ability of a computer to hold ones and zeros for either a short term or until the computer is turned off. That's what temporary means. That means the second you turn it off, it's kind of like turning your phone off. It clears all, and you have more memory when you turn it back on because it has removed everything, and only the programs that load back up load their memory back. Okay. It is generally, it's also called RAM. I don't think I have that on the screen here, but RAM is an acronym. So it'd probably be more helpful if you actually use that term RAM because that is more specific on the type of memory. Probably should have I probably should have that in the slide here. RAM. It stands for Random Access Memory, and it simply is called that because unlike the device we're going to talk about next, the hard drive, you can access any location in the same amount of time. Think to give you an analogy, think of the old VHS tapes. You remember the kind you put in the VCR, and if you wanted to watch something that was an hour into the video, you had to fast forward, fast forward, fast forward, fast forward, and then you could hit play. Think of a DVD where you could just say, go to that one spot, and it instantly jumps to the 1 hour mark. So that's kind of like what I mean by random access. It can randomly access any point versus what we're going to talk about in the next video, which is hard drives. Memory is measured by its capacity, which are measured with bytes. Now, I didn't talk about a lot about this back when we talked about ones and zeros before, but we had ones and zeros. 8 ones and zeros together made up 1 byte. If you remember that, we had 8 bits to a byte. So a byte. Think of a byte as one letter of the alphabet. If you remember back, we stored ASCII values, and an A was a code, and J was a code, and X was a code. Well, each of those required 1 byte. I say that because when you have a Word document that has 5,000 words in it, each word may be 5 to 12 letters. Well, that gives you kind of a math problem of how many bytes would be in that file. Pictures would have about approximately 3 bytes per dot because we have red, green, and blue, each of those being a byte. We talked about that in a previous video. Um, so, well, I'm going to come back to how bytes are used and how memory is used on a practical scale. Let me finish this slide. I'm going to demonstrate in Windows how this works. A few companies. Now, unlike CPUs, there are dozens of companies that make memory. Memory is a much cheaper process to manufacture or a cheaper product to manufacture. So therefore, you have many companies, especially over in Southeast Asia, that design memory. So a couple that are very popular: Crucial, Corsair, Buffalo, Kingston. In fact, we're going to go shopping here in a few minutes once we finish hard drives and look at prices of CPUs, memory, and hard drives. And you'll see some of these names. You'll also see, my mind escaped me, but we'll see some other manufacturers. So know at least one, maybe two of these names. Maybe remember the two C's, Crucial and Corsair. Now, we talk about in CPUs, they're measured in 3, 4, 5 gigahertz. Well, in memory, generally you're going to see between 4 and 16 gigabytes. Remember, gigabyte would be a billion bytes. You will see more on some high-end computers, but If you go to a typical Best Buy and look at their computers, you're going to see 4, 8, 16 gigabytes. How much memory do you need? Well, we're going to get to that in the next video. In the next slide, I will kind of show you what happened when you didn't have enough memory, and why it's important to have enough memory, and how to tell whether you need more memory. So we're going to come back to the next slide. Actually, no, we're not. So right now, let's look at memory. Now, I'm going to return to this same program I was using earlier. Remember, if you want to look on your computer and see what your computer is doing, hit Control, Alternate, Delete, hold all 3 keys down, and then you'll see Task Manager. So if you click Task Manager, it gives you a list of processes. Think of these as programs or apps. And we already talked about the CPU column. We also have the memory column over here. Now I'm going to click the title here to sort. And you're going to see that Photoshop is the program that is using the most memory. Well, that's actually not true, because Chrome is doing something a little sneaky. If you notice here, basically each tab of Chrome is using a different process, which means that Chrome is one of my tabs is using 633 megabytes. That's 633,000 kilobytes. So this is 633 megabytes. Another tab using 600. Another tab is 500. So if you add all that up, Chrome is probably actually using the most memory on my computer. Other programs are using memory. OBS, which I am recording this video in, is using 300 megs. SketchUp is using 350 megs. Premiere Pro is using 558 megabytes. So to answer a question from a few moments ago, how much memory do you need? It depends. Are you a do one thing at a time kind of user, or are you a multitask user? Do you like to, you can see from my browser windows and my I'm not sure if I can show you my, let's see, my taskbar. Is it going to, nope, it's kind of hidden on the screen. My taskbar has at least 12 or 14 programs. You can see a lot of them listed right here. Chrome, OBS, SketchUp, Adobe Premiere, Picasa. Bryce was the program we were working on earlier with that mountain render. Dropbox. So all these programs are using up memory. So if you come up here, in fact, my physical memory is 76% full. I believe if you go to performance, it'll kind of graph that and say you're using about 12 out of your 16. I have 16,000 megabytes. It would be nice if they used the same scale here, but they keep changing. So for example, here it's in kilobytes, and on this screen it's in megabytes. But it is what it is. So I have approximately 12 gigs used out of 16, and that's fine if I don't use any more. I can go up to 16. You can actually use more than 16, and something not so good happens. Nothing bad happens, but it slows your computer down. Let's just put it that way. And I'll demonstrate that in a moment. You can actually have a graph here of your memory usage. So for example, if I were to close down Adobe Premiere, let's close it down. I don't think I'm needing it at the moment. It's going to ask me to save. Now look at this graph right here. It should drop a little bit. Yeah, see a little tiny dip. Maybe hard to see on your screen, but it dipped a little bit when I closed Premiere. So you can kind of see how much each program is using up. Now, again, let me just repeat to make sure we're clear what this memory is. Excel may have hundreds of numbers on the screen. Every one of those numbers has to be in RAM or memory, or they would just disappear. My slide right here on Google, all these words right here are in memory. It doesn't mean the CPU is using them right now, but in memory is holding all these words. I must have some images I'm working on for these slides, possibly in Photoshop. All those images are in memory. When you open up your Word document and start typing, those words that you type are going straight into memory. Remember, who's putting them into memory? The operating system is finding a spot for them in memory, and so you don't have to worry about it. Now, have you ever been typing a paper and the power went out or Word crashed? If that happens before you hit the save button, you've lost everything because it was only in memory, and memory is temporary. So just a little bit of a visual here of how memory works practically speaking. Again, we're going to look at it in a buyer's guide here in a moment in another video, but you can see which program is using the most memory. Photoshop is. followed by, well, actually, like I told you earlier, Chrome was probably using the most. See, I don't think I need Picasa at the moment. I was using Picasa to show you all those mountain images from a previous video. So if I close that down, now we have only 10 gigs, well, 10.9 gigs. So we have, more memory. Now, one of the negative aspects of running out of memory, and I think I actually have this on a future slide, so I may be getting ahead of myself. Yes, this concept right here of swap files, virtual memory, and page faults. These all mean the same thing. Most people just call it the swap file. To explain this, let's go back again one more time to many years ago when I first started using computers to see how they were different and how they work better now. If I was using a computer, a program, and one thing to understand is back then computers didn't have so much memory. A typical computer had 4 megabytes of memory, 8 megabytes, not gigabytes, megabytes, so 1,000 times less memory. If I was using a program and it ran out of memory, I tried to store too much numbers in Excel, then the program would just crash and stop working. It was done. It just had out of memory and it would close down. A game might do that. If something went wrong with the game, it would just close the game down. Nowadays, and I say nowadays, starting in the mid-90s, computers, this is really with the beginning of Windows, when Windows first came around, they started using what's called a swap file. Now, a swap file is, you ran out of memory, so I'm going to put all the values that you need to store but don't have room on your hard drive, which we're going to get to in a moment in more detail in the next video. Just understand that the hard drives are much slower. Remember, I said here, memory is fast. Hard drives are slow. So, therefore, anytime you have to start dumping things to a hard drive, your computer slows down. How about another analogy? Hopefully this makes sense. You have all kinds of storage in your house. You have storage, technically your dining room table could be storage if you want it to be, and it's right there, easy to grab. You have closets. Maybe you have things that you don't use very often, you put in a closet. Maybe you have an attic, and you store some things in the attic, and those are things like Christmas decorations you don't use very often. It's slow to go get them. Is it not? Is it slower to go into an attic than it is to go to your dining room table? Think of the dining room table, which is probably not a great place to store things, but it's fast. If you want to grab something, you walk by it, you grab it in seconds, versus digging through a closet or going to an attic, or worse, let's say you rent a storage facility and you store, furniture in a storage, and you have to drive 6 miles down the road to get to it. So that would be kind of like your hard drive. Yes, it's yours. Yes, you hold on to it. Yes, you can get it whenever you want it, but it takes you a lot longer to get to it. That's why you always want to avoid that process by buying as much RAM as possible. This is probably the one thing that's probably more important than your CPU when you're buying a computer. I told you earlier that you want to look at this number and how fast it is, but it's worse to have run out of memory than it is to have a slow CPU. So basically my recommendation on memory is always to buy as much as you can reasonably afford, and then maybe go a little bit more. 4 is on the really low end. I would never buy a computer with only 4 gigs of RAM. 8 would be adequate, and then 16 would be great. But again, I have 16 because I do a lot of video. I multitask. I don't close down a lot of programs at one time. Again, if you open a program, work on it, close it. Work on another program, close it. Then you're in a candidate for not needing a lot of memory because you probably won't fill up 8 gigs. But as you can see, I'm already right now at 11 gigs or so, so I definitely need 16 gigs in my computer. So we'll look at shopping for that in a future video. But for this video, just remember, memory is also called RAM. It is temporary storage. It is the fastest storage. It is measured in bytes, generally between 4 and 16 gigabytes. And companies would be Crucial, Corsair, Buffalo, Kingston, and I think that's all. And again, the idea of swap file, I'm going to revisit on hard drive. So you can either write that down for memory or hard drives because it affects both of them. So that is the second requirement or responsibility of the operating system. Let's go back here. So Windows, too far back. Windows is working with your CPU. It's also storing addresses in memory on those little chips right there.